My name is Jeff Rich. I'm an astronomer and the outreach lead here at Carnegie Observatories. We're in the plate vault. We're in our archive of data going all the way back to the beginning of the observatory, and even a little bit before that. So this is where we store all of the data taken by scientists who were part of the Carnegie Institution. This is all of our data, at least all of the plates. The plates in our vault come from all of the telescopes that our astronomers worked on. I like to say ours is the coolest because we have so many different projects by so many different scientists that it spans just a huge range of stuff. The plates in this archive, the spectra, the images, they would be from the telescopes that we had a part in running for the length of the institution. So that's all the telescopes on Mount Wilson. There are some Kenwood plates from Hale's private observatory that he brought with him from Chicago. The plates from Palomar Observatory, specifically the 200-inch and the Schmidt telescope. And we also have plates from our observatory at Las Campanas, just started in the late 60s, early 70s. We used plates for a really long time, even after digital technology was starting to supplant that. Plates are really, really high resolution. They're very fine grain as opposed to early digital detectors. The actual physical scale of the pixels is, not as fine as the grain in a chemical emulsion. But a good example of another reason that we kept using plates is this giant one here. This is from Las Campanas. It was taken at the DuPont Telescope. The physical scale of this plate is the size of the image that you're taking at the telescope. Filling this space with silicon, like actual physical digital detectors, is, well, only very recently being realized at telescopes. Like, within the last few years, astronomers have been building bigger and bigger arrays of detectors. So if you wanted to use the full potential of this telescope with a full field of view, you had to use a plate. So this telescope and some other telescopes had people using plates even up through the 90s when we were starting to switch from plates to digital detectors. You can see the really, really nice detail on the image, so it tells you that Las Campanas is a really good place to take data and that plates are really fine resolution. But it's also got notes all over it. The VAR plate, which has this massive, VAR on it, is pretty normal for astronomers. When they were working, they would take notes on the plates, write things down. The VAR plate was October 1923. What you can see is, so these are all Andromeda. So all of these are plates from that survey. Scientifically, the only way that you knew it was a variable star and not just a nova is because I was observing it again and again, and so realized that this was one of those Cepheids that Henrietta Leavitt said were so useful for measuring distance, so then came back. He kept observing again and again and again and again and again, and the frequency of observations increases as you go along, because he was doing a survey and getting a scientific answer. If we ever were to, say, digitize our collection, to scan the plates, you would have to clean them off if you want to do a real proper scan. So it's a dilemma, right? You don't want to erase someone's work, but if you want the data done properly, there would have been a lot more room when there were less plates, so you could imagine folks actually doing work in this space. The plates are not just sitting here never to be touched again, they are data, and we do get requests from folks less often now than in the past, obviously, but there are folks who might read a paper that was published by a scientist who observed at Mount Wilson or Palomar, or even Las Campanas in some cases, and they want to see that data, so we have it. A couple of years ago, there was an astronomer who was reading a paper that was written about 100 years ago. He wasn't reading the paper because he was digging for old stuff. What he noticed was there was this white dwarf, which is a stellar remnant, that had a funny spectrum. It had been labeled as unusual way back when it was first observed by an astronomer on Mount Wilson in 1917. So, gets the original journal paper, finds the name of the author, the date of the observation, because the person wrote it in this paper, sent an email to us asking, could I take a look at the spectrum? Because we know now that those kind of unusual signatures in white dwarfs are probably from possible planets that were orbiting the star before it went through the end of its life and shrunk down to a white dwarf. So we came down here, found the plate. Luckily, it was one of the spectra in one of these drawers. Sent the spectrum off, and sure enough, it was what we call a polluted white dwarf. So it had evidence of exoplanets in its spectrum, taken here up on Mount Wilson 100 years ago. Just didn't know what it was at the time. This room is pretty much all images of the sun and spectra of the sun and drawings of the sun. The sun was studied in enormous detail over many, many decades in addition to the night sky. And there's even more on that side of the boxes. Hale built the Kenwood Observatory at his home. It was a solar observatory. He loved studying the sun. So he's got these plates here. And the first telescopes at Mount Wilson were solar telescopes. The Snow Solar Telescope, which was brought from back east over here. And then the 60-foot and 150-foot solar towers, which were constructed, original constructions up there. The original drawings, the white light drawings that are done up there, are actually in our archive here. So we have the originals. This one is cool because UCLA ran the 150-foot for a while. They digitized all of the data, so there is a digital archive of every single drawing, sunspot drawing done at Mount Wilson. It seems really analog that someone is still doing a sunspot drawing every day, but the data are useful. Folks want them, and it's a continuous, mostly unbroken record of the sun from the same observatory, done the same way for over 100 years. This first room that we're in is mostly spectra. So light from, say, a star, a galaxy, or whatever it is you want, it's split into a little rainbow. These are really, really, really important because you can get all of the physics out of them. You get lots and lots and lots of information from spectra, even though they're not really visually exciting. We don't usually pull things out unless they're actually requested to protect things. We want them to be safe. We don't want to break them. We don't want to smudge them. So in general, we keep things in the shelves, in the envelopes. So we have a few examples on this light box to make life easy. The really, really big, long piece of glass is a piece of the sun spectrum. It has a couple of the strongest lines in the sun, labeled H and K. So this is 4,000 to 4,100 angstroms. So that's 100 angstroms, about 10 nanometers. It's a really tiny piece of the spectrum in the blue. But you can see in great detail what's going on in the sun. Every single one of these, this is a negative, so the bright parts are dark bands. All of those are different lines in the spectrum. And the other spectra that we have here, these are spectra of other astrophysical objects. So this is a stellar spectrum. I think this one is as well. But I like them because it shows how physically tiny the actual physical scale of the data. I'm much younger. I've only had to work with digital data. It's already in the computer. It would have been interesting to think about, you know, there's all these machines sitting around which would have been used to actually like analyze and take the measurements. And in addition to the astronomers who worked here, there were computers as well for many, many years. We're lucky that Hidden Figures got made, because I can just say, have you seen Hidden Figures? That tells the story of the women who were computers involved in the space program. Computers have always been around in science for a very long time. And in many cases, they are quite hidden. In our case, we know their names, we know they worked here. We have a yearbook every year, so we can go and say, I can give you the list of the women who worked as computers here, but they weren't given credit as, say, co-authors on the science papers. In addition to the scientists, they would have been helping do the physical work to make the measurements on those things and write them down to actually do the sciencey bit. We think there's at least 250,000, so about 250,000 plates or more in here. There was an effort to archive all of the direct image plates, but all of the spectra and the solar data, we don't have an archive of it. We know roughly what it consists of, but unfortunately you can't say, go type in a search for, was this spectrum taken at Mount Wilson? But we do have a searchable archive of our images, so if you wanted to find out if, you know, there's a picture of your favorite galaxy taken in our archive, you can go find it. We keep this data because you never know what cool things you might find later on.